So we're supposed to use the limit definition of the derivative to show that the derivative does not exist at x equals 6. For a derivative to exist at a certain location, the derivative as you approach it from the left and from the right have to agree. And we could do it, well, I don't think at this point we've done anything other than the limit definition of the derivative, so I'll save that other way to consider this problem. So we're supposed to evaluate the limit as x approaches 6 from the left. And if we're approaching 6 from the left, that means we're using this piece of the piecewise function. So the y value, as we get infinitely closer to 6 from the left, is 6. And the x value is going to look like this. Now, the numerator is definitely going to be 0. The denominator is going to get infinitely close to 0. But this is 0 divided by something getting infinitely close to 0, so we can say that that limit's going to be 0. And the idea is that a derivative is telling you how fast something is changing, right? If we're constantly spitting out the y value of 6, no matter what the value of x is, then it's not changing at all. The slope is 0. So here, the limit as x approaches 6 from the right, that needs this part of the piecewise function. So here, we're going to substitute x, because that's the y value that we're getting out of the function. Okay, so we put x, the limit as x approaches 6 from the right, and the f of x value is going to be equal to x. We'll keep it in its algebraic form. And so if you simplify this before trying to evaluate the limit, like we did up here, it's x minus 6 divided by x minus 6. That's 1, because it's the same expression divided by itself. So x divided by 6, x minus 6 divided by x minus 6 is just 1. And the limit as x approaches 6 from the right of a constant 1 is just going to be 1. So they're not the same. Therefore, the derivative does not exist at x equals 6.